All right. First of all, thank you everyone for joining this panel today. We are very excited to be here, Gus and I. So I am Ritu Barkotoky. I work for Amsted Automotive. It's a tier 1 automotive supplier. And we have Dr. Ghassan Kridli. He's the Dean of College of Engineering and Computer Science at University of Michigan, Dearborn. Okay. So today we are going to talk about a very important topic that's the preparing to enter an industry that's undergoing a tremendous change. And before we dive into it, we would like to provide a little bit of a background of myself and what qualifies me to speak in front of you. So I am Ritu. I work in human resources for a tier 1 automotive supplier, Amsted Automotive. We are headquartered in Saginaw, Michigan. My job title is Director of People Development. I oversee talent development, talent management, succession planning. I work mostly with the engineers and our business development team and manufacturing team. So our company essentially is, it specializes on high efficiency mechatronic clutch designs and also advanced powder metal and metallurgy solutions and products for top OEMs. So that being said, we are, as an industry, as a company, in the midst of automotive transformation or mobility transformation. So, it's no news. Mobility industry in general is trying to identify new technologies for, automotive and transportation alternatives. Whether it's you're an OEM or a supplier or a startup. And very recently, I read an article on McKinsey.com that talked about drivers in Munich waste about 87 hours in traffic. And that number is, for Los Angeles, it's about 119 hours. And worldwide, we have 1.3 billion vehicles on road. So as you can see, there are a lot of vehicles on road, and that sometimes creates a lot of congestion, traffic issues. And that can, for some countries, it can be worse than the others, and especially in developing countries. And almost all of are from India, and I am from India. I moved to the US almost 2 decades ago, and the place that I am from, whenever I go there, I see a lot of traffic and congestion. So that being said, governments and people are interested in learning about alternative options and alternative transportation modes, so to speak. So McKinsey actually did a survey in 2022, and 70% of their respondents were positively inclined to use autonomous shuttles with 3 other passengers in the next decade. And 30% of the respondents were inclined to use e-scooters and e-bikes in the next decade or so. So that being said, we are, as a society, we are interested in moving towards more of a broader, solution for mobility. And I was surprised, actually, by the results, pleasantly, because in my mind, all I hear when I think about mobility industry, moving toward transformation, all I hear is that people are not ready. We are not ready as a society, and people are not ready for it. But government is going to play a role in it. A lot of regulations have been enacted, more so in some countries than the others, and that's going to play a very big role as we move into the mobility industry or transform it. So that being said, I would like to turn it over to Dr. Gus, just so to share his perspective is in terms of why it is important to prepare for mobility industry transformation.
All right. Good morning. I think it's still morning. It's Saturday. I lose track of my time. I'm Ghassan, or Gus Kridli. I have the pleasure of serving as Dean of the College of Engineering and Computer Science at the University of Michigan, Dearborn. And I would say part of what I'm going to talk about is related to why I'm here also. And that's, Ritu mentioned, being a supplier, or she works in talent acquisition and so on, where we're also talent providers. So if you think about industry, you have the OEMs and the suppliers. We are a supplier to everybody. So for us, it's really important to be able to prepare the talent. So to give you some of my background, and before I get there, I will say And part of what we do is to consult with industry to prepare the talent. And Ashwini is on my board, and that's how I ended up being here. So I appreciate the invite and the ability to talk to you. So my background is, I'm a mechanical engineer by education. And I spent, so just like everybody else gets a PhD, you either go to industry or academia. I ended up in academia. But my passion has always been in how to translate industrial need into our educational programs. So I actually spent, as a faculty, we talk about student internships and co-ops. I spent 2 years with Chrysler, 2 years with, at that time, and 2 years with Ford, working side by their engineers. In one case, I had to actually even go to the plant and market ideas or sell ideas that we were trying to implement or their engineering was trying to implement. So I was one of the people who worked with them to try to convince the union that, show them data and facts that this is safe to implement. So this is something that I needed to take to the classroom. So when I talk to my students, I actually, would be providing them with real talent and real knowledge. So I did most of my work in sheet metal forming, and now I'm more passionate as dean about preparing the talent. So throughout this presentation, I will talk about what we're doing at Dearborn. And just like I ask my students, or allow them to have cheat sheets, I have my own cheat sheet. So I'm going to be looking at it. So one of the things is,
Sorry, I forgot to move the slides.
Okay, no worries. Yeah, we don't have too many slides, but I think one of the things that we think about mobility, and it's a really broad subject, and one of the aspects of it is why are we talking mobility, not transportation, or well, transportation is the action, but why not automotive? And the thing is, we want to be as broad as possible. The thing is, we want to impact the quality of life of people. So what's the point if we have a bus system or a flying car or whatever transportation mode, if a person cannot get to the station, right? So we think about mobility in the broadest sense. And as we think about mobility, we have to think about, the population in the world, in the US in particular, is aging. And what is the need for the population, the aging population? I'll give you, a few things that we're working on in academia, but that also requires us to work together with industry in developing these solutions. So defining mobility by itself is not a simple task because it involves a lot more than just moving people or transporting people, developing transportation solutions. We have to really think about what we're doing with bicycle lanes. So how is that affecting traffic in these communities? How are the rider's safety? We have a colleague who actually has a LiDAR system on his bike and rides it around towns and captures, what happens. And his goal is safety, bicycle safety. So if you think about it, we're talking about now, he says every time he rides, it's almost 8 near misses or near hits, let's say, right? So it's really dangerous because we're not used to driving with bicycles side by side. Cities have ordinances. They have laws that says how far, if there's no bike lane, how far you have to be away from the bike. I happen to know Dearborn, you have to be at least 5 feet, drive 5 feet away. But are we adjusting to these new realities and new modes of transportation and mobility? We have to also understand and accept these solutions. But as a society, we have to accept how many of us are willing to accept an autonomous vehicle taking our kid to school and dropping them off without us being in the vehicle, right? And in a bus, we're comfortable. There are people that are adults. And then we have to think about their impact on society. Any solution we have has to have will have an impact on somebody's life. If we think about, we develop bicycles and we narrow the roads, we're making maybe some traffic congestion in some areas in town. If we move to electric vehicles, we're impacting the people who were in the internal combustion engines. And we can see it now. I'm sure in your companies, you see the demand for mechanical engineers versus electrical engineers. So we've shifted demand from one profession to another. I can tell you at my college, we have gone from mechanical engineering 3 years ago being the largest department in the college with over 1,000 students to now computer science being the largest department with 1,200 students. Just think about how it impacts a college when we shift to meet the needs of industry. Another thing that I wanted to mention is, we have to think about sustainability. We see how flooding in New York this weekend or yesterday, storms are getting stronger, causing more headaches for communities, and we need to think about sustainability in our solutions. One of the things I would share also is something from personal experience. We think about what we have in this country and in more, I'd say, technically advanced countries where we start taking people's interests into account. I had a child who, she was in a wheelchair, and I had to live the struggle of, or my wife and I had to live the struggle of navigating around the world when we travel. So some places have, you go to the airport, the wheelchair gets you to the plane, but they don't bring it back. You'll have to carry the child all the way to the belt where they give you the wheelchair, they put it on the belt. Their society is not used to the idea of, serving the needs of somebody who has a different mobility need. Places have sidewalks that are stepped. There's nowhere to get the wheelchair on the sidewalk. So I can lift the wheelchair, but the wheelchair user could not move, right? So these are things that we have to take into account as we think about mobility. One of the things, so just giving you this background is to say that the solution is not simple. It's not only technical also. It's technical, it requires both social scientists, engineers, computer scientists. You put everybody together, and that's where it becomes, how do I develop a program in mobility? And we have a lot of them around. Is it mobility from a technical point of view? Am I talking about societal aspect of mobility, future cities type program? So that's a challenge, and that's a challenge that requires collaboration, and that's where Ritu and I can talk about her needs as a corporate need, and my ability to produce the right kind of engineers. So for us, it's an opportunity and a challenge, right? It's an opportunity because it's exciting, it's new times, we're getting new solutions. So if you're in academia, you love to get to work on new problems. But it's a challenge because it's evolving rapidly. And if you think about, people talk about the pace of academic growth and development, it takes time, and I'll talk about this later on. But that's the challenge. How do we make ourselves even more agile as universities? So this is kind of my introduction into the topic. I would like to, ask Ritu now, like from an industrial point of view, from a corporate point of view, how do you go about acquiring talent, and what kind of skills do you look for?
All right. Well, thank you for the overview and the nuances with changes in mobility needs and industry. And that's a brilliant question. So obviously we need collaboration between corporations and universities, because if we work in silos, we are not going to be able to make the difference that we want to make. So again, talent in mobility industry is obviously undergoing a tremendous transformation as well, because eventually the ICE vehicles will become less in numbers, and electric vehicles and battery electric vehicles will take over. And with that said, the skills that will be very important in the near future would be knowledge of chemistry, metallurgy, supply chain demand, programming language, artificial intelligence, machine learning, as well as electrical, electronics, and mechatronics engineering degrees or knowledge of it. So generally speaking, don't take my word for it because I don't have an engineering degree. Electric vehicles can be less complex to build than the ICE vehicles. With that, there can be certain skills that will become obsolete, and new skills may need to be learned. So there is another side to the skill set. If I think in terms of OEM and suppliers, most times suppliers work with OEMs to identify the right solution, whether it's changes in the process, some specification changes or product changes. So most suppliers have to work directly with the OEMs to identify those needs. So sometimes, because the mobility industry is changing so rapidly, and electric vehicles and BEV technologies are so new, OEMs and suppliers are learning together, and out third party also, the vendors, they are all learning it together. And that can be a bit tricky, messy, and a bit of a frustrating back and forth process because everybody's trying to figure solutions out together. So it is important to have technical skills as well as non-technical skills as we move in the new mobility space. So when I talk about non-technical skill sets, so what are they? What comes to my mind is as the mobility industry is changing, one skill that comes to mind, and it's going to be very, very prominent, is resilience. So what resilience means is we are able to bounce back from failure. So as we are trying something new, whether we are doing at work or trying a new skill, maybe we are learning to skate or rock climb, it's tough, right? And there is a possibility that we will fail. So how do we develop resilience? How do we create a mindset that we know this is new for us, but we will fail and we will bounce back. So that skill set is also going to be very, very important. Another skill set that comes to mind is active listening. So active listening we can all use, right? Whether we are an engineer, an employee, an organizational leader, we all can use active listening. So what active listening means? Can anyone share what active listening means? Anyone knows? What do we mean by active listening? Yes. So when we actively listen or practice active listening, we are focusing on the speaker more than ourselves. We are not focusing on what question we are going to ask next, and what's coming up next. So basically, we are being in the moment, and we are trying to understand what's being said and what's not being said, because sometimes that also helps in order to identify a solution. Because when you're having these conversations with the suppliers, OEMs, third-party vendors, and you're trying to solve an issue, sometimes you have to think between the lines, read between the lines, and try to understand what solutions we can provide. Maybe the customer even doesn't know about it yet. So one other skill that I know, I did speak to some of our engineers and business leaders in terms of, obviously, as I was doing my research, in terms of what skills they think that they want their engineers, in their engineers. So one thing that came up was ambiguity. So to be able to deal with, ambiguity, to be able to be okay with ambiguity. So what ambiguity means is, when we have a situation, we don't have a clear answer. So nowadays, in our fingertip, we have, supply of information. If we don't have if we have a question, we can find the exact answer, more or less, and we are just used to getting the exact right answer on our fingertips. But when we don't have the answer, and if we are being trained to find the right answer all the time so easily, it is very, very difficult to be okay with, the information that we don't have. So how do we teach students to be, okay with ambiguity is also very, very critical. And then, needless to say, and we have been saying it, throughout, that, through this mobility transformation, organizations and the next skill set, actually, not only is important for engineers or students, but it is also important for organizations, and that's risk-taking. So, and risk-taking is done very well by mostly technology companies. I don't know if anybody is here from any technology company. You are? Okay, you can probably agree or not agree. So technology industries do very well in terms of risk taking, and mobility industry now is becoming part of technology industry, or we are just collaborating. So mobility industry, is also, it's going to be very important that we focus on risk-taking behavior, and we encourage our employees or students, in fact, to practice risk-taking. So what risk-taking means is that we have the courage to find alternative solutions. We don't, when somebody gives us an answer, and if we think that this is not the right answer, there's a better way to do it or better way to find it, we just don't stop. We ask questions, we ask whys, and we are okay to dig deeper and understand what's the right answer. So, I have given you a lot of skill set in terms of non-technical and technical. And how do we create an engineering entrepreneurship is the question. And with that being said, I would like to turn it over to Dr. Gus to talk about your perspective in terms of University of Michigan, Dearborn, how it's approaching enhancing student talent and skill set to prepare them for mobility industry transformation.
Thanks, Ritu. I mean, this is a really tall order for any university to think about, how we prepare people for mobility transformations. But I think going to your point, which is how to feel comfortable with ambiguity, because this is something, if I'm designing a brake system, it's not well defined, but it's much more defined than to say I'm developing a mobility solution. And so we have a few things, and these are part of the things that we do and we can do together. But I can tell you a few things. So we making sure. So we work with students on open-ended problems. Anybody who's an engineer, might have taken a course in statics or dynamics where we were told, given the area is so and so or the length is so and so. How do you work with something that's not given? How do you go and search for that is what we're trying to teach students. So there is a paradigm shift now in the way we educate. There's a paradigm shift that will differentiate between universities. There are some programs that will excel and be more desirable to you as industry practitioners, if you're in industry, to attract students and recruit students from, and there are some that will stagnate. Thankfully, we're in Michigan, and we have all the great industrial base around us to guide us. And that's, I can imagine if I were in a rural area in the middle of a farming state, that I won't have access to the talent from industry to guide me as an engineering dean. So my graduates will be more traditional graduates. So what we're doing now is, so we're focusing on project-based learning. And what we mean by that is giving open-ended problems. Everybody knows engineering 100 or 101 is, you have a project, you have a senior design project, but now we're threading it through the curriculum. So it's not book-ended, it's across the curriculum. And with the kinds of projects we're working on, we're asking students to think about, use the term entrepreneur or entrepreneurial engineering. We're actually part of a partnership of universities with a foundation that is working on entrepreneurial-minded learning. What that means is everybody, we're all, as when we want to educate or prepare engineers, we want them to be curious. What are the problems and what are we, how do we address these problems? Connecting knowledge. So if I'm thinking about, going to EVs and as a solution, electric batteries and so on. Now I shifted my emphasis, geopolitical emphasis, from the Middle East to maybe Bolivia, maybe China, with the materials that are coming in. So what is the impact on my supply chain? So as an engineering college, I have to get the students to think about connecting this knowledge. When I develop a solution, what happens to that solution? What happens to the community? If we have a community, we have all these gas stations. If they're going to go away, what happens to the infrastructure, the gas station owners? Are we going to get eyesores because electric batteries take longer time to charge and we need more spaces? So we have to think about educating the engineers to consider these aspects. And the last thing is creating value. My graduates will have to create value for whoever the user is. If it's you, your corporation, your division, if it's a single user, we have to create value. So this is one way that engineering colleges differentiate themselves. And thankfully in Michigan, we have quite a few colleges that are really focused. So I can brag about Dearborn because I know what Dearborn is doing, but I'm sure that other universities in the region are doing a good job as well. So we also have developed mobility degrees. What does that mean? And I think, so the mobility degrees from my college would be different from a mobility-related degree from a business school or from an arts and science perspective. We try to make them broad, but if you think about how many credit hours are in a degree, a master's degree to be specialized in mobility is 30 credit hours. I can barely cover technical aspects that you require as a company to help with that degree. Yes, we do have the degrees. We revamped a degree that was purely automotive. We said it's automotive and mobility systems engineering now. It's one of our largest degree programs that attracts talent, and it attracts a lot of talent from India as well. So we have Indian students who are attracted to our degree program. And being in Michigan, the automotive capital of the world, is kind of our region here. We get a lot of students who are attracted to this degree. But there are other things that we need to do. So if you think in the short term, we have a lot of professionals. I mentioned my mechanical engineering being the largest to being the third largest in the college now, with electrical maintaining their place and growing. But you may not need a full degree. Maybe your company needs quick training. So we can do different ways, and that's where, as I said, universities are innovating, but we also need to innovate with you. So when we talk about micro-credentials, maybe you just need a certificate. You just need somebody who is an AI expert. So we can do that. So we can work together with you to develop that tool. We can say stackable credentials. This is something that all our master's programs now at the University of Michigan Dearborn use this. Anything we develop new or anything we revamp is basically taking these micro-credentials, stacking them. So if you have 2 or 3 certificates, you may need a core course or 2 and get a master's degree. So you can incrementally get your degree program. We can do training none for credit. And we're exploring something now. It's not there yet, but what we're exploring is, can I create training none for credit that I can add a little bit more assessment into it and use it for a student to get credit or replace credit? The cost of education is another factor. Can I make it cheaper and less expensive for the student to get a master's degree? So we're looking at that. We don't have a solution, but we're exploring that option as a College of Engineering. And then innovation partnerships. We're always looking for connections with industry. I said I spent time in industry. I have an industry advisory board, and I always look for people who can guide me, who can tell me what to do and how to make my programs more relevant, more ready to address your needs. This is an example of a great partnership we have with Ford Motor Company. So Ford has an alliances program. The idea of it is they have alliances. They have one with Michigan, one with MIT, I think one with Stanford. So they have multiple alliances with major universities. Being part of the University of Michigan Dearborn is also part of the alliance. So we actually, when they have we get about 1/3 of the projects that advancing technology projects with Ford. This is a great example where, if you think about, Ford did very well with a trailer backup system that they implemented a few years ago. The math behind it, the control system, was developed in Dearborn, right? So this is where Professor Shim is one of our colleagues who was recognized by Ford. His name is on all their patents to get the program going. But this is something we can do. Ford is one company, but we're willing to open. As a university, we're agnostic to, we're looking for partners. Our goal is to graduate students who meet your needs, right? So we are looking to partner with any university to work on addressing these needs. It's really important to listen, and not just to have a meeting and have partners telling us what is needed, and we just say, oh, great, we've done our work. We need to listen and give you the programs. the fact that things are moving really fast is also a challenge for us. So I'm gonna stop for the sake of time. I don't want to keep talking. I can talk. I'm a professor. I can talk forever. But I'm gonna ask Ritu. So you talked about talent, and you said what you look for in talent. But how do you retain it? Things are the market is extremely kind of moving now rapidly, and people moving around. So how do you keep the talent?
Sure. So yeah, I can probably sit here. It's fine. When we think of talent from our organization perspective, we look at it from a few different angles, in terms of talent acquisition, talent retention, and also positioning talent. Like positioning our organization to the talent. What are we doing internally that's great, that people like within our company? How do we market it and show it externally to the world that people actually want to work for us? So that's another aspect of our talent strategy. So attracting talent, again, I'm going to take a step back before we come to retention, and I'm going to talk about attracting talent. So like you said, you partner with organizations. We also have been partnering with universities to attract talent and find opportunities to collaborate. So we do that through co-op programs, internships, and also from time to time, our engineers actually volunteer at universities, during the design competitions, and they also go and help students in some of their design projects. As well as some of our engineers, they also go to high schools and middle schools to promote engineering and metallurgy and the advanced metal forming solutions that we kind of specialize in. So we look for partnerships as well in terms of attraction, and we also look at talent acquisition from diversity, equity, and inclusion perspective. I am the DEI lead for our organization, so that's kind of falls under my umbrella or my duties. That how do we expand our reach? If we are doing the same thing over and over again, we are going to get the same results. So in order to get a different result, we have to do things differently. So how do we create that expansion? What is missing right now that we need to address and we need to kind of expand? So from DEI perspective, we have been going to new universities for career fairs or partnerships that we had never done before. And that could be Society of Women Engineers and Society of Hispanic Professional Engineers and Thurgood Marshall College Fund. It's a long one. So those are the things we are doing. And at the same time, in terms of retention, we do think that organizational culture, and it's not just me talking, most organizations here will say the same thing in terms of, if you want to retain your employees, think about your culture. How can you improve your culture? How can you give your employees the development, the skill set that they need for now and for future? And what's their career path? What growth you're going to give them are the important questions for our organization. And I'm going to say, no way we are perfect, but we know that it is important and we want to continuously look at it and address it. And the third one is, how are we positioning ourselves in front of the students and any employees, prospective employees? So I would say, we use social media. We have been constantly trying to create or enhance our website. And we have been constantly trying to enhance our presence on LinkedIn, Facebook, to attract the new generation and so on. I would say we have done some, but that's a long way, and that's part of our talent strategy, and more to come. So hopefully, maybe next time, I can share more ideas and more information on the things that we have done and that have been successful. So with that said, Dr. Gus, I have my cheat sheet for your questions that I have prepared for you. So with that said, I would like to turn it over to you in terms of what universities are doing to be more agile in meeting the rapidly evolving talent needs of mobility industry.
So thank you. I think one of the things, we're as universities, we're told that you're slow, and there's a lot of reasons why we are. But developing a brand new program, yes, we are slow, because we need to make sure that we're meeting the needs of our customer, which is industry. So we do consulting. The faculty develop something. It goes through an iterative phase of going back and forth. So that may take a year to 2 years, and that may not be fast enough. However, what I have here is if you need a special course, I can be delivering a special course. If we can develop a special course, I can be delivering it in January, right? If it's a training course, it could be next month. So I think we're becoming more attuned to the needs, and we figure out that we need to move faster. If I develop a program now on EVs based on today's technology, by the time it's offered, it's going to be obsolete, right? So we really have to think about these micro-credentials, the quick programs, the short programs that we do. We also are preparing our students. So you used the term ambiguity before. We say we like them to be comfortable with being uncomfortable, right? So, we want them to feel that I don't have to have the solution and the answers now. I will get to them. We make them think about the process rather than the end, the means to the end. And I can tell you, in my exams when I taught, a student could have a completely wrong answer, but showed me the right process and would have gotten a passing grade. If somebody got a wrong answer because of time crunch and said, I'm not sure why, this doesn't make sense, to me, that's a huge value, because then the person knows that this just doesn't make sense, I don't have time to fix it. To me, that means this person is a critical thinker. So we really think about educating students not to be machines, not to be kind of, going through the motions, but rather to be creative and critical thinkers. We are, as I said, willing to partner, and I hope all of you partner with universities, whether you're here or in other places in your region, to think about how we can make sure that our educational programs meet your needs. I always look for volunteers. I always look for, we have, the college has its own boards, but every department in engineering and computer science in any college around the country has to have a board from industry guiding its programs and operations. A lot of departments use it as just a way to get their accreditation and make sure that the program really, they discuss their assessment with the board. But we actually use our boards to get feedback on programs. Every one of our new degree programs initiated through a discussion at an advisory board from industry. So this is kind of what we're doing and trying to be fast in meeting the needs of industry. So I'll stop here. I don't know.
Sure. What time is it? Is it almost time?
Yeah, 5
or?
minutes.
Could you 5 minutes for the audience?
Sure, yeah. If you have any question, I guess we are wrapping up.
Yeah, my name is Rashmi. I come from Bosch. I'm responsible for airbags North America. One of the challenges that we are seeing in the industry is, in our area at least, there is a lot of vehicle architectures changing, which is driving, it has a lot of impact on safety, cybersecurity, on a daily basis. So I'm curious to understand how you are defining curriculums for some of these areas, because customers themselves are kind of figuring it out, or
Well,
it's very uncertain. So.
Yeah, this is, first of all, great question. And I didn't talk about it. I had it in my notes. I didn't talk about it for the sake of time. But we're organizing at Dearborn. I can speak about what I'm doing at Dearborn. So we have departments. You have mechanical engineering, computer science, electrical engineering, but we're doing crosses. So cybersecurity is a theme, right? And we are working on a center where the faculty from the different disciplines are addressing the cybersecurity problems together. So we have the people who are looking at grid cybersecurity from a charging station point of view, right? We have people who are looking at the CAN bus in a vehicle. How can we prevent penetration into it? So maybe it's a charging station, but it could be other ways of cyber attacks. We're looking at even the power grid, the national power grid or the local power grid. So we are actually interweaving is the right word, I don't know, just getting cybersecurity across. We have a full degree in cybersecurity and quality assurance. So you can do it that way, or you can do it as courses within programs. So our automotive and mobility program has a course on cybersecurity. I hope this helps. But we're, again, if this is something we would really would love to have, right, we'd love to have somebody from Bosch telling us what, are we doing it right? And if we're not, how we should do it right.
Sure. And of course, it really comes from also the OEMs with the vehicle network architectures, that has a lot of influence on security, and now security has influence on safety. And It's been trickling down problem as we uncover this whole mystery. Okay.
Yeah, thanks.
Thank
And safety is the other one. We actually have a group that's working on safety and active safety systems.
Prashant Patel, Caliber Technologies. We are an engineering consulting company here in Detroit area. And I have just maybe more than a question, maybe a thought that what university taught me, at least to me, is a basic skill. Like I'm a mechanical engineer by trade, and most of my background is purely mechanical engineering. And when the EV came, I think one thing that university can do is prepare engineers with the fundamentals knowledge. Because once you have that fundamental knowledge, what you want to build on that foundation, whether it's a commercial building or the residential building, I think that becomes a little bit individual's role and their desire, and they have the skills. So if university provides fundamental knowledge, then it would not really matter whether what applications you are applying to, whether it's a EV application or whatever. I think the fundamental skills like thermodynamics you learn, right? So you can apply thermodynamics for engine cooling, but at the same time, you can apply that for the battery cooling, right? So the principle and fundamentals remain the same. And if engineers have learned fundamentals, I feel like learning focus should be more on fundamentals than maybe learning applications. Because once you learn application, you are just expert in that field. So I feel like if university focus is on that, the applications and how industry evolves will naturally be taken care of with that idea. So that's just a few comments.
Well, I would say it's music to my ears, because I really, that's where, getting the faculty, the department chairs who actually run the curriculum, that's really what we talk about the students. You're an engineer first. Mechanical is just the application area that you're working with. It took us years, but now let's say our control class, it's one lab that is used for mechanical, electrical engineers. Control theory is control theory. What you're controlling is the, what you need to focus on as a mechanical versus electrical. So now we're getting there. The charge to my department chairs this semester is to create more of these links. We want also, to break the boundaries between departments. And you're absolutely right. I mean, that's really what we should be doing.
Thank you.
As I'm just adverse to what he was saying on the fundamentals. Even the fundamentals are shifting. Software and a chip. I don't think we have that much chip industry. Happening around Michigan, even though we have the car companies transforming themselves. Imagining autonomous, braking in between and then going to EV. So what's your university doing on educating kids on the new set of software? That's going to ride on the chips. Rather than just outside.
Right. So that's more in the computer science. So we do have computer science and software engineering. So within so the two fields are computer science, software engineering, artificial intelligence, cybersecurity. They're part on the computing side. Cybersecurity crosses to the engineering side, and so does artificial intelligence. But yeah, so we are. So our automotive and mobility systems engineering program has actually got software courses in it. Now, they're not software, they're engineers, not software developers. But we do, if somebody wants to have the skills in software, we do have programming for them. Again, we need guidance to make sure that we're teaching the right things. And I'm not saying just me, every university. And tomorrow I'm going to a meeting with the engineers dean in Michigan. All the engineers deans meet once a year. So these are things that we discuss collectively. And so I appreciate your comment, absolutely. Yeah.
All right. Thank you, Ritu and Dr. Ghas. So very informative.
Very interesting talks.
We're breaking for lunch now, right?
Yeah, yeah, and then we meet back again in the grand ballroom.
Nice presentation. Next is 2 o'clock, right? That Venkatesh, yeah.